Here we go. This is the second day of factoring, and in order to factor, you need to understand how to distribute, right? Because factoring is really distributive property backwards. So let's do number one, a review of distribution. We're going to take the 2x to the third and distribute it. 2x to the third times 3, that's 6x to the third. 2x to the third times negative 4x to the fourth, that is negative 8x to the seventh. If you don't know how I'm doing this, you take the coefficient 2, multiply it by the coefficient negative 4, you're going to get the coefficient negative 8. And then x to the third times x to the fourth, add the exponents, it becomes x to the seventh. Last but not least, 2x to the third times x to the second, what do I get? Positive what? 2x to the fifth. Excellent. And that's how you distribute. If you don't know how to do this, there is no way that you're ever going to be able to factor. You need to be able to distribute in order to understand how to factor. Okay? So let's go to the next problem, which is factoring. And factoring is a reverse distributive property. So you look at all your terms. There's 4 terms in this polynomial. 1, 2, 3, 4. And you want to pull out what's in common. So what do all 4 terms have?
Exponents.
Well, okay. They're definitely x's. So this is what I'm going to do. I'm going to put parentheses down here. And I want to start figuring out my GCF, my greatest common factor. Emphasis on the G, greatest. Right? You don't want to just say, I'm going to pull out an x. You want to pull out the greatest amount of x's. So if you have x to the fourth right here, like you could pull out x to the fourth. You could pull out 4 x's from this one. You could pull out 4 x's from this one, but you can't pull out 4 x's from this one. So what is the greatest amount of x's that you could simultaneously pull out of all terms at the same time? 3. 3 is the greatest amount of x's that you could pull out of all terms at the same time. So part of my GCF is going to be an x to the third. Okay. Now, in addition to 3 x's that I could pull out from here, 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 and here, there's also a multiple that I could pull out of the 8, the 16, the 40, and the 12. What is that multiple? It's 4, right? Some of us are thinking 8, right? Because 8, there's 8 right here, there's 8 right here, 8 times 5 is 40. But 8 times what is 12? It doesn't work. So 4 is the actual biggest multiple that you could pull out. So the GCF really is 4x to the third. Let me repeat that. The GCF really is 4x to the third. So if you do pull out that 4x to the third, this is where you do reverse distributive property. In other words, 4x to the third times what would get you that 8x to the fourth? Yep, 2x. And you're thinking coefficient 4 times what coefficient will give me 8? Well, that's a 2. X to the third times what will get me x to the fourth? That's a x to the 1. How about the second term? What will be right there? In other words, 4 times what will give us a minus 16? A negative 4. And then how about those x's? X to the third times how many x's will give me x to the seventh? X to the fourth. There we go. And the next term, 4x to the third times what will give me a 40x to the third? 10? Do I need x's? No. Because if I put an x right there, x to the third times x will give me x to the fourth. And we know that you don't want it to change. You want it to be x to the third. Now listen to this, guys. If you're going through the process of saying, okay, 4 times what will get me 40? Okay, 4 times 10 will get me 40. X to the third times what will get me x to the third? I mean, technically you could put a 1, right? But that's not going to do anything, right? It's not going to change anything because 10 times 1 is still 10. So let's not even bother putting the 1 right there. We're just going to leave it 10. How about that last term? 4x to the third times what will get us a negative 12x to the fifth? A negative 3x to the second. And that is factoring. You get it? Good. Could we please look at our notes that we started the other day? Day 1 was all of this beginning part, distributing. What is factoring? It's distributive property backwards. And we learned how to pull out the GCF. And then we stopped right here. We stopped right here. And we said this is going to be day 2. So we already know how to pull out the GCF. We already know that if I look at number 5 right here, I'm looking at all three terms and thinking, okay, the 12, the -8, and the 4, what multiple is in common right there? There's definitely a 4. And then there's also x's in all the terms. There's an x to the 7th, an x squared, and an x to the 5th. What's the greatest amount of x's I could pull out? X squared. So I could figure out my GCF just by looking at all the terms. And then you could figure out what's left over on the inside. In other words, 4x squared times what is 12x to the 7th? That would be 3x to the 5th. And so on and so on. You guys already have this done. I just wanted to start reviewing right there, because what if I asked you to factor a polynomial that does not have something in common in all of its terms? So as you can see here, you might be thinking, oh, 12 and 15, I could pull out a 3. I could pull out a 3 from here, a 3 from there. Wait a minute, I can't pull out a 3 from there. Or you might be thinking, oh, I could pull out an a from all the terms. There's an a squared there, there's an a there, there's an a there, but there's no a over here. So how about b's? Well, there's b's, 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 but there's no b here. So there is no GCF that you could pull out of all 4 terms at the same time. So we're kind of stuck right here until we learn about factoring by grouping. So if we look up here, we'll get back to that one later, but let's look up here, and we're going to learn a method called factoring by grouping. Okay? Factoring by grouping is simply separating a polynomial into two groups. And you know what? I might as well start labeling this. If you separate a polynomial into 2 groups, that right there is step 1, just to let you know. Okay? And then after that, you factor something out of the first group and you factor something out of the second group. That's technically step 2. And then step 3 is to take a step back and factor something in common out of the whole thing. I know that sounds way confusing right now, okay? And I even did this wrong. This should have been red, that should have been green. Check this out. I have a polynomial right here. If I asked you factor, you're going to be like, okay, what's the GCF? X's? No, there's no x, right? So there's no numbers out in the front either. So we're kind of stuck, but we're going to use this method. Step 1 is to separate it into 2 groups. As a matter of fact, check this out. Over here, there's an explanation. I would like you to just do a little tiny note. It says step 1, and then put like a little bracket right here. Separate it into 2 groups. That is step 1. Okay? And let's show you what I mean by separating it into 2 groups. You have 4 terms. Simply take the first 2, write it there. Take the second 2, write it there. There's some obvious space between it. Everybody should be able to do step 1, right? Let's go to step 2 over here on the side. Step 2, put a bracket right here. Factor something out of each group. Okay, everybody right now, please put a bracket right here and put step 2. That way you know that this is step 2, factoring something out of each group. Step 1 is to make 2 groups. Step 2 is to factor something out of each group. So let me go over here and let me show you how I did that. So let's ignore all this work. So I look at my first group and I factor whatever I can. What could I pull out of that first group? 2 x's, but I'm not going to write it as 2x. I want to write it as x squared, right? Yeah. Now, what would be left over on the inside? X plus 1. Now, let's take a look at the second group. What could I pull out of the second group? Nothing, right? But because we're doing factoring by grouping, I'm gonna force a 1 out of there, which doesn't change anything, right? I'm going to force a positive 1 out of there. And if I pull out a positive 1, nothing changes. It's still going to be an x plus 1, right?
Wait, okay. Isn't there always a 1 in front of the x's, and it would be a 1?
Yeah, so what I'm doing is I'm pulling out that 1 even though it's still there, right? Now, I know that seems weird. This is the first time you see this. Just bear with me here. The point is you have to pull something out of the first group and you have to pull something out of the second group. If you can't pull out anything, then pull out a 1 just to go through the motions. Now, let's look at, that's exactly what I had down here, right? I just wanted to show you how I got to here. Does that make sense so far? Okay, step 1, I made 2 groups. Step 2, pull something out of the first group, pull something out of the second group. Even if you can't pull out something, pull out a 1. So this is where we are now. Now let's go to step 3. And I want you to put a bracket on step 3 also right here. Right here, bracket on step 3. Step 3, so what's in common in both groups? You look at the common binomial, and there happens to be a common binomial of x plus 1. And we're going to factor that out. Okay, this is the weirdest part right here. Check this out. Again, let me ignore the answer. But I'm going to take a look at this first group that I already pulled out an x squared, the second group that I pulled out a 1, and I'm going to take a step back and look at the first group and realize that there's an x plus 1 right here. And there's the same exact binomial x plus 1 right there. So what I'm going to do is I'm going to pull out the x plus 1. Check this out. I'm going to put some exaggerated parentheses right here. And out here on the side, I'm going to pull out the x plus 1. And if I pull out an x plus 1 from this x squared, then I will have an x squared left over. The x squared is just left over right there. And there's a blank spot right here because I pulled out the x plus 1. And if I pull out this x plus 1, then there's going to be a plus 1 left over in there. And there's my blank spot. And that's it. It's factoring by grouping. Check it out. If we look at our answer, the only difference between this and the final answer is that right here I exaggerated the parentheses. So you could visually see that I pulled out, step 3 is to pull out that common binomial. So I took the x plus 1 here and the x plus 1 there and I pulled it out. I factored it out. So if I pull out the x plus 1, there's an x squared left over and there's a 1 left over. I left the blank spots there so you could visually see that the x plus 1s are gone. But if you write it with the correct size parentheses, just x plus 1 times x squared plus 1. Believe it or not, if you take this binomial and multiply it by this binomial, x times x squared is x to the third. X times 1 is x. 1 times x squared is x squared. 1 times 1 is 1. This is the factored form of the cubic polynomial above. All right, so if that's confusing, it's okay. This is pretty much the steps right here. Step 1, separate it into 2 groups. Step 2, factor something out of each group. Step 3, factor the common binomial from both groups. Okay? So let's look at some more examples. Down here it says that I'm going to do it. You're going to follow along. Everybody, even before jumping into grouping, right? Even before separating into 2 groups, you're supposed to say, could you pull out anything in common in all the terms? Is there x's in all the terms? No. Is there 4's in all the terms? No. So after trying to factor out the GCF, then you say, okay, let me try grouping. So step 1 on grouping is what? Separate them. So everybody together, please, let's write down x squared plus 4x. You're going to have to write kind of tiny. And then leave a space. And then put positive x plus 4. So please separate it into 2 groups the way I did right there. Now, what is step 2?
You have to check it
Factor something out of each group. So let's take a look at that first group. What's in common here and here? X. So let's pull out that x right there, yeah? Now, what would I have left over if I pull out an x? X plus 4. Perfect. Now, I know that this is the binomial that I want over here also, and I already see it there, right? So if I try to pull something out of here, there's nothing to pull out. So what am I going to pull out when I can't pull out anything? A 1. So I'm going to pull out a positive 1. And what's left over on the inside? The x plus 4. And that is a great thing because we have an x plus 4 here and an x plus 4 there. And step 3 is to take a step back and pull out that common binomial in both groups. So I'm going to put a giant parenthesis right here. And then out here in the front, I'm going to put an x plus 4. Why? Because I'm pulling out this x plus 4 and I'm pulling out that x plus 4. It's going to be out here. So the x and the 1 come down. That's all there is left. There's an x and there's a plus 1. And I am done.
So there will always be a plus 1 in the answer?
No, not always. What's the point of me making the parentheses so big? This is because we're barely starting, and I need you to understand that, look, there's a big blank spot there and a big blank spot there. That's because I pulled out the x plus 4s. They're gone. Okay? The only reason I'm giving you this giant parenthesis is so you could visually make the connection, right? Okay, the x plus 4 is out of there. So, of course, the correct size parenthesis, x plus 4, x plus 1. That's your answer. Now, a lot of people, I've seen this in the past, if I just go from this part to this answer just like that, they'll be like, what the heck happened, right? But if I exaggerate the huge parentheses with this blank spot, it helps people understand that the x plus 4 and the x plus 4 get pulled out. So the x comes down, the 1 comes down, and that's your final answer.
Wait, so there would not always be a plus 1?
There's not always going to be a plus 1. Let's take a look at the next one. You'll see that that's not the case on number 2 right here. Once again, the first thing to always try to do is pull out something in common in all the terms. So you might be thinking, oh, there's an x in all the terms. There's not. Or maybe there's a y in all the terms. No, there's not. Maybe there's a multiple of 3 in all the terms. There's not. This is not a multiple of 3. So after trying to pull out the GCF in every single term, then you try grouping. Step 1 on grouping is to make 2 groups. Let's do that. 9x squared minus 3xy. Space, positive 6x minus 2y. That's step 1, making 2 groups. Step 2, factor something out of the first group, factor something out of the second group. So on the first group, what could I pull out? There's a 3, absolutely, and an x. So there's a 3x that I could pull out, right? If I pull out a 3x, 3x times what gets me a 9x squared? 3x. Okay, and then 3x times what gets me a negative 3xy? Negative 1y. And we don't really need the 1, so I'm just going to erase it. I'm just going to leave it a negative y. So 3x minus y is that binomial inside of the parentheses. Now let's look at the second group, and what could I pull out of the second group? There's a 6 and a 2. What could I pull out? 2. So let me put parentheses. Let me pull out a positive 2. And if it's a positive 2, please put a plus sign. You'll see why in a couple of seconds. Now, what's left over on the inside?
3x minus
A 3x minus y, right? 2 times what is 6x? 3x. 2 times what is negative 2y? Negative y. Now, here's step 3, the most confusing part to some students, is where you take a step back and you pull out the common binomial in both groups. That's right. The 3x minus y is what we're pulling out from both groups. So I put that 3x minus y out there in the front. See, here's a binomial 3x minus y. Here's a binomial 3x minus y. I'm pulling it out from both groups. So what's going to be left over on the inside?
3x plus 2.
That's right, 3x plus 2. 3x plus 2. Now, of course, these parentheses are exaggerated. So let's write it with the correct sized parenthesis. It would be 3x minus y, and it would be 3x plus 2.
Would it be wrong if we put our answer with like huge parentheses like that?
It's not wrong. I always do it to help students understand what's happening. Yeah, it's the same thing. Yeah. So again, when they say factor, it's really a reverse distributive property. In other words, if I were to distribute 3x times 3x, it'll give me 9x squared. If I were to distribute like 3x times 2, that'll give me a 6x, and there's a 6x right there. If I distribute negative y times 3x, that'll give me a negative 3xy. If I go negative y times positive 2, it'll give me a negative 2y. So if you're ever doubting yourself, if you did factoring by grouping correctly, you could always distribute and see if it gives you the above polynomial, which it does. Okay, so I've done those first 2. I want you guys to try number 3 right now. Go for it. All right, guys, you should have step 1 separated into 2 groups. So you got 2x squared minus 4x, and then leave some space, positive x minus 2. Step 2, factor something out of the first group. In other words, look, I'm ignoring the second part right now. I'm just going to look at those two terms and think, what could I pull out of both terms? What could I pull out of both terms right there? A 2x. And if I pull out a 2x, 2x times what gets me a 2x squared? That's just an x, okay. And then how about 2x times what gets me a negative 4x? That's a minus 2, right? Okay, I hope everybody gets that. So now you factored from the first group. Now let's look at the second group. And let's ask ourselves, what could I pull out of the second group? Well, nothing. But what am I going to pull out? A 1. So I'm going to pull out a positive 1 out here. What's going to be left on the inside? The same exact thing, the x minus 2. Nothing changed. Now, that is a great thing. Why is that? Because step 3 is to take a step back and pull out that common binomial in both terms. We have an x minus 2 there and an x minus 2 there. I'm going to put some exaggerated parentheses. And out here, I'm going to pull out that common binomial in both groups of x minus 2. Right? This guy and this guy come out. And on the inside, you just have a 2x and a 1 left over.
Wait, so, okay, let's just say that inside of the parentheses, there was x plus 2 and then the 1.
Obviously, we don't want those exaggerated parentheses. Let's just go x minus 2, 2x plus 1. Okay? Number 4 right here. Have you guys tried this one? Try it, please. Step 1, make two groups. 2x squared plus 2x space positive 3x plus 3. Factor something out of your first group. What could you pull out of that first group? A 2 and an x. If I pull out a 2 and an x, what's going to be left over on the inside? X plus 1. Let's take a look at the second group. And the second group, what could we pull out of there? A positive 3. If I pull out a positive 3, what's going to be left on the inside? X plus 1. Now, luckily, we have the same binomial here and here. If you ended up with different binomials, you'd be stuck. You couldn't continue factoring. But because we have an identical binomial, a common binomial in both groups, I could now take a step back and factor out that common binomial, x plus 1 in both groups. So I'm going to put some exaggerated parentheses. Out here, I'm going to put the binomial x plus 1, and the 2x simply comes down, and the plus 3 simply comes down. And that's my answer. But with the correct size parentheses, it's going to be x plus 1, parentheses, 2x plus 3. Ta-da! Done. What do you guys think?
Easy.
Now, let's go to our homework. Now, there's still more. There's still more to the notes. But right now, we're going to go to our homework. And let's take a look at number 13 on our homework. We stopped on number 13 because 13, we can't pull out the GCF. You're thinking x, 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 there's no x. Oh, 8, there's a multiple of 2, multiple of 2, multiple of 2, there's no multiple of 2. So the first method of pulling out the GCF doesn't work. That's when we move on to the second method by grouping. So we're going to split it into two groups, x squared plus 4x space plus 2x plus 8. And in the first group, what could we pull out? X. In the second group, what could we pull out?
2.
Positive 2, okay. And if I pull out an x from the first group, what's going to be left in here? X plus 4. And if I pull out a 2 from these guys, what's going to be left in there? X plus 4 also.
I mean, once you figure out the first one, it should be fine.
Yeah, once you figure out the first one, the second one should be the same, but it's not always going to be the same. Sometimes it's not factorable. Sometimes you might have to pull out an additional negative 1. But anyway, let's now put some exaggerated parentheses, put the x plus 4, that common binomial, we're going to take it out of that exaggerated parenthesis, and the x comes down, and the plus 2 comes down, and there's your answer, x plus 4 times x plus 2.
What if it's the other way around? Like you wrote it the other way?
If you write it the other way around, it's totally fine because of commutative property of multiplication. You could switch the order of multiplication, you get the same answer. 2 times 3 is the same thing as 3 times 2. So if you had x plus 2 times x plus 4, it's perfectly fine. Let me try this guy. Well, I want to make a separate video for all these questions, but right now I want to try 15 because it's a great idea to begin with the first method of factoring. What's the very first thing we learn on how to factor? Pulling out the GCF. Right? Even before factoring by grouping, we pull out the GCF. Is there a GCF in all 4 terms right here?
No.
Yeah.
Yes, the
2. Okay. So let's actually do that. Let's put a 2 out here, bracket. On the inside, I want to have a 2b squared, a minus 6b, a plus 1b, and a minus 3. Yeah, the brackets look cooler than parentheses. I'm just kidding. I mean, you could use parentheses if you want. But see, the reason why I'm using brackets is because after you pull out that 2, I'm going to ignore the outside 2, and I'm going to pretend that this is the new polynomial that I'm dealing with, and I'm going to use grouping on this. Okay? So right here, I'm going to group it. I want to do my first group, my second group. Check it out. 2b squared minus 6b, and then my second group, leave some space, plus b minus 3. So in this first group, what could I pull out? A 2 and a b. So 2b times what will get us a 2b squared? That's b. And then 2b times what gets us a negative 6b? Minus 3. Now let's go to the other one. And what could we pull out of the other one? Nothing. So what am I going to pull out? A positive 1. Pull out a positive 1. What's going to be left on the inside? B minus 3. And now we could take a step back, do some exaggerated parentheses, and we could pull out this common binomial of b minus 3. So the b minus 3 is out here on the outside, and on the inside I'd have a 2b left over and a plus 1. So let's write our answer with the correct size parentheses, and let's not forget that there was a 2 out here in the front. So our final answer is going to be 2, parenthesis b minus 3, parenthesis 2b plus 1. Ta-da!
So you could even...
Is it difficult? Yes, it's difficult. I'm not going to lie. Will it become easier? That's totally up to you if you practice. If you practice, it becomes easy, all right? So I'll make another, this is already a huge video, so I'll make another video explaining the rest of these.